All right. Well, hello, everybody. Welcome. Thank you very much for joining us. My name is Tanner Watt. I'm a municipal programs specialist with Local Authority Services. This is a new procurement group event focused on electrification of fleet vehicles. So just quick introduction of who LAS and Canoe is. LAS is the business services wing of the Association of Municipalities of Ontario. So we are the Ontario organization behind Canoe, and Canoe itself is the group that brings together all of the different provincial organizations across Canada to help extend the scale of the group buying benefits that we're able to extend to our members. So as you can see in the map there, we've got most of the country covered, and I think we have attendees today from just about every province. So special welcome to those joining from coast to coast. So today we are joined by quite a few representatives from the companies that participate in Canoe to talk about what they're working on in regards to electrification. To start with, we've got John Stadola, Government Sales Manager with Toro; John Hurst, Senior Director at the Center for Technology Research and Innovation with Toro; George McIntyre, Product Manager for Case; Robert Newt, Service Technical Manager for Case; Eric Lewis, Government Channel Sales Manager with Case; and Greg Dean, Vice President, Sales and Brand with Zamboni. So a couple of housekeeping notes before we get started. We are recording this event. It'll be available on the LAS YouTube channel and our website afterwards. We will be sending a follow-up email to everybody who registered, likely this afternoon or tomorrow morning. It'll have a link to that, and you'll have contact information for all of our presenters today. Each one of our companies here is going to do a presentation on what they're working on. Toro is going to speak to the smaller equipment, grounds maintenance. Case is going to go through the medium and heavy duty equipment. And then Zamboni is going to share their experience, which is a lot longer than many, with electric ice resurfacers. There'll be roughly a 15 to 20 minute presentation for each, followed by a Q&A period. So if you have questions as we're going through the presentation, we'll use the Q&A feature built into Zoom to ask those. So you'll type in your questions. There's a little Q&A box on your screen. Click on that. You can type in your question at any time. After the presentation is done, we'll go through those and answer them. So with that, we will hand it off to Toro.
All right. Thank you, Tanner. Need to get my screen set up here and we'll be off and going. All right. Well, so thanks everyone for the opportunity to talk with you today. I think Tanner's done a great job, lined up some really great companies from different parts of the industries that give you a good inside view into kind of how we're looking at the opportunity in front of us. So as Tanner mentioned, John Hurst, Senior Director for the Center for Technology Research and Innovation at the Toro Company. You see if you're not familiar with Toro, obviously we're very strong in the outdoor powered segment, but we have a lot of brands that are within the Toro Company, and they're listed on the bottom of the screen there just for greater familiarity. Through this process, I guess as going through this, I've been with Toro for over 22 years. And it's been a phenomenal journey. I've been really excited to see the journey we've been on the last few years as we move into electrification and different elements of not only electrification, but also just alternative fuels over the years. But one of the things that I've always found that resonates with me with the Toro Company is just what we're about. And it aligns with my personal values, the company values. It's really throughout the customer. It's about, making beautiful outdoor space, but being highly productive and sustainable as we do it, right? So it's a constant focus on how to make creative solutions, how do we innovate while we're providing the performance our customers need. But under that umbrella is, having it look beautiful, but using less water to do it, using less fuel, making things more efficient through there. So that's really that triangulation of wins that we get excited about, especially on kind of the advanced R&D and the visional creative sides, is how do we help solve customer problems, but continue to challenge ourselves every year with doing it with less resources and otherwise. So as we go through the presentation, obviously, from the Toro company, going to use a lot of examples for our products, but I also try to pull in things from around the environment and the different influencing factors, just to kind of not make it a Toro sales pitch, but certainly understand maybe how we think about the problem and opportunity, and how we think about what things influence the distance or the trajectory that we go. So not knowing kind of the broad audience, some of you might be already well on your journey with electrification. Some of you might be still kind of partway through, or you've taken that first step, and others might be, why would we even talk about it? So I always like to just start with the problem statement of why electrify, right? So as the Toro company looks at this, we see kind of three primary buckets. First and foremost, like I said on that first slide, is really customer needs. What's the customer needs that's driving the electrification? And this can be from all the different elements we talked about doing less with more, about a desire to improve the environment, about the desire to improve the outdoor space without having all the noise, right? That's one of the big benefits. What's another big driver? Regulations, right? So we see a lot of regulations. We're located down here in the States. Certainly seen a lot of regulations that are following kind of along lines with European regulations that are driving in over here. Up in Canada, you have a lot of regulations coming in front of you, I think, right? You have a 2035 initiative coming your way that's going to drive your daily life, whether it's your automotive, in the businesses that we interact with or otherwise. And it's all really under the umbrella of how do we reduce our carbon footprint? I look at it as kind of the camper model of leave it better than it was when you left it. And so how do we do all this, and how do we effectively be productive while improving our overall environmental stewardship? So I mentioned kind of outside influences, right? So one of the things that in our advanced R&D group, or the role that we play in link with the divisions, is what things are happening outside of the Toro company that's going to influence our customers, influence our decisions. And certainly when you talk about electrification, front and center for all of us is electric products, right? Electric vehicles, EVs. And this has been an exciting, step change in the world around us. If you look at the last 10 years or even the last 5 years, where went from a select few to really drive into the mainstream, drive into the big OEMs, Ford and Volkswagen and others, and the early entrants like Tesla really substantially taking a significant step forward with market share and penetration, and things like Ford, right? So Ford, traditional OEM, looking out and seeing that, from their viewpoint, based off analytics and whatever else, they see, EVs being 50% of their sales by 2030 across the globe, which in itself is an interesting statement for what you call a traditional OEM, but even more so that a year ago, their vision was it was going to be 40%. So even in the last year, they've significantly shifted their view on that. And again, how does that matter to our space? Because as this outside space and the fleets that we pull into work with, or the other vehicles that are on the road, move to our electric, regulations will continue, and just customer demand is going to continue to increase as more and more customers have an EV and they experience an EV and understand the benefit of having an EV. Kind of want to take a step back and maybe a little education around how to help you think through this. And really, I'll go through some examples, and it's a lot of text, but the general theme here is, just because you have, say, a 50 horsepower powered product today doesn't mean you're expecting a similar power performance when you go to electrification. And a lot of that is in the efficiency. So really this first bucket is just to take a look and recognize that, if any of you have been around this, like a gallon of diesel fuel has a substantial power capability to it. It's like 43 kilowatts of power, right? In itself, you'd say, okay, well, Tesla's got 90 kilowatt hours, right? So, I mean, wow, how's that work? How can you only have like essentially 2 gallons of diesel fuel on board? But the reality is a lot of it is so much is lost in ICE engines with efficiency, right? Diesel, gas, otherwise, like you everything you put in, you're getting like 25% out. So the theme here is, if I have a piece of equipment that today's 215 kilowatts equivalent in electrical with 5 gallons of diesel, I'm putting 215 in, my engine's giving me 25% of that, my actual working load is just under 54, right? So you lose so much, and it's just in heat and losses through there. As you look to electrification route, you might have a 28 kilowatt hour pack to begin with. Your inverter, you lose just a little bit. Your motor, you lose a little bit. But really 28 goes in, 24 comes out to say the wheels, we'll call it, which is obviously less than your 54 that we were talking about there before. But we have a lot of other things that benefit that experience in terms of recharging, regenerative braking, things like that can put it back in, or boost charging, let's say, or boost performance if it's in a hybrid application. So really just the theme here is, as you are moving through this journey, there's a trust element which, as you're working with OEMs, whether it's, Zamboni, Case, or the Toro company, that we're going to provide you with a product that we feel is going to meet or exceed your needs. And sometimes through there, there's a learning process about kind of what power is on board and how it's being used. But the general message is, as you electrify, things have become significantly more efficient, and we're not just burning fuel to release it to heat. This is an example that I like to pull forward to really drive the point home. So a number of years ago, as we were looking at a hybrid solution that we introduced again a number of years ago, we went out and actively collected data on a golf course using a fairway mower. And really the idea was, we know that all of us, we design for kind of the extreme, right? Like you always have to have that extreme case that really drives all your specs down. So here's a mower that I think had like a 50 horsepower engine on it. And as it was being utilized and driven, we captured the data, and you can see that generally for probably 50%, it's using less than 15 horsepower. You step up the chain and there's very few moments where it's actually using 24 horsepower, kind of a peak demand. So as we went through that process, we designed a hybrid solution where we could significantly decrease the size of the engine by using a hybrid solution in there to really provide that boost power, kind of boost when needed. And it enabled a significant improvement in terms of reducing the engine size, which obviously had a direct correlation to less fuel usage, and it really right-sized the power, and it gave a kind of immediate power when it was needed. So, that's an example with our Toro Realmaster 5010H of leveraging the capability of electrification, still with a hybrid kind of, diesel solution, but taking that first step on there. So, even part of this, as you go through the journey, there's the full step to electrification. There's a step in there where you could say, look, it's a big product XYZ, maybe a hybrid is a good intermediate step, or an alternate fuel. And it's an example of how we've utilized that technology to optimize an application there. Step into another example. This is our E-Triflex, so fairway mower, can be a greens mower as well. But one of the things from the Toro company standpoint that we like to do is engage with industry partners, such as yourselves, to understand kind of where you are in your journey, what information is valuable or helpful for you as you're looking at how you step into it. And that can be from a product standpoint, from an infrastructure standpoint, to a business operations standpoint. And this is just a really great example. Obviously, if you love golf or love the history of the sport whatsoever, St. Andrews is, the mecca of golf. It's where it originated. And we had an opportunity with the group in St. Andrews to do a study. So as we looked to through that process, it was equipping units and going out and essentially collecting data as they were leading up to the 150th Open last year to understand what is the benefit or the drawbacks of moving to electric. And really the message out of it is, and this was published by the Geo Foundation for Sustainable Golf, is they saw like a 90% reduction in carbon dioxide emissions by using the all-electric fleet at the 150th last year in terms of the E-Triflex. They also saw some substantial decrease in cost. So as part of this journey, as you go through, there's the capital investment, there's the operation expense, and by and large, as you move to electric, the capital investment goes up, but your operating expense goes way down. So it's important to look at both sides of the ledger as you move through this journey. And Tanner, I'm not sure if you want to jump in and answer that question right now or catch that later on.
I think we can catch that at the end.
Okay, perfect. I guess the other comment about that is, as we're going through this, as Tanner mentioned, we will have some Q&A after we go through the slides. So certainly feel free to post those now. We can click those at the end. I think one question that I would have for the broader audience is really, as you look at electrification, what's the big challenge in front of you? What's the big hurdle or big opportunity that you look at that you have questions that you need help with? How could a company like Toro or Case or Zamboni help you through that? Is just whether it be education or what's the right size products or what's the journey you're on. So feel free to post those in the chats and we'll follow up on questions at the end. So moving along back to talk about kind of that both sides of the equation, right? So that the capital expenditure for maybe the equipment cost being higher with operational ownership. And this was a good slide to really draw that forward as we look at the Toro company combined with solutions that we have available today. So, if you focus on the pictures, which I always do first, right? We have a broad assortment in kind of the contract professional space, whether it's handheld backpack blowers on our 60-volt system. We've got right-on zero-turn machines that are launching. We've got construction that works obviously specifically very well for indoor construction because it's all electric, non-emission, and other power equipment in there. But one of the things that we look at is obviously as part of this journey is what is the cost of ownership. So this is an example, and I'll send a link to a calculator, but it's really, as you look at, if you kind of add everything up in terms of what you're using today for say a gas version and you move over to battery, if you throw everything in, including the capital investment difference, for a product such as say this stand-on Revolution series mower, your total net is about $107 savings per month, right? So if you set aside the benefits to the noise, the benefit to the operator that's using it, to the environmental side, from just a pure dollar standpoint, it's $107 per month. Taking that one step further, if you said, look, okay, my capital is over here and we depreciate it XYZ over here, what's my OpEx budget actually look like? If you just looked at the OpEx side, I mean, you're well over $4,000 a year in savings to move over to electric, which that's about $345 a month. And again, the link is there, and certainly Tanner sends out the follow-up. We can send a link to that, but it jumps over to our site that has this line of products. It's not funny math in there. I mean, you can put in what your cost of your petrol is today. You can put in what your capital expense is, and you kind of see the numbers. And it's really kind of a telling story to help you kind of think about the journey through there. And maybe my personal experience and having not only used these products, but on the 345 difference in operating cost per month. If you have an EV today, and much like maybe many of you, I do have a Tesla, that number is real. Like when I compare my fuel savings versus my electric charging cost right now, I'm well over saving $345 a month. And that doesn't even take into account service intervals, oil changes, all that other stuff. So I mean, it's a number that's been materialized out of our experience with these products, but I'd say it's very much validated in the real world use if you look at just even the EV models. So that's a fun one if you want to jump on there and take a look at kind of a cost of ownership structure. The other segue I wanted to jump over to is, you think about electrified product, and you only think kind of traditional electrified. At the Toro company, we understand that there's another part of that equation about driving customer needs, and that's really around labor optimization of that. So we're significantly investing in the kind of the robotics space, again, under the same questions of why do you do that? But the reason why I pulled that forward here is because there is an electrification play, whether it's the robot on the left that we've introduced and we'll be launching here soon. It's all battery powered, all electric. To the product on the right, which is a GeoLynx autonomous fairway mower. It's been unveiled at the golf show, and again, that's another good example. In that case, it's a hybrid, but it's much like my other hybrid play. It's a smaller engine on there to have the hybrids. You kind of get the best of both worlds. So as you think about kind of product portfolio, this is another thing that will be coming into play in not only the electrified space but also the labor side to help you accomplish your work and your jobs. One of the questions that I often get when we talk about electrification is this infrastructure piece. And if I'm talking to a golf course or a landscape contractor, like their head starts to spin thinking about what is my world going to look like here? Do I have to have a big, bus charging depot? Do I need to have all these trailers that have power capacity? Do you need to put in solar and backup battery? And the answer generally, as you move into this, is yes. You need to consider these as you move through it, but a lot of it can be, mindful planning. And certainly this is where we often work with our partners to say, what is your roadmap? And is this you looking to convert your fleet in 2 years and 10 years? What does that journey look like? If the case of examples like this, where, we look at it obviously from our product line, but we also recognize the fact that if you're at a golf course, you have fleet vehicles, EVs that are coming and pulling in. You have other equipment like maybe a case, a backhoe or otherwise that needs to be part of that process. So it's trying to encompass that overall vision to help you work through a journey to get there to have a solution that meets your needs. And then the other question that comes out often is the hydrogen conversation. And generally, again, back to EVs, hydrogen's coming online. We certainly know there's opportunity. My view on it right now is that automotive has moved so far forward with battery that hydrogen is going to have a hard play there. In kind of the outward look. But if you think about, this example from Toyota, as you move up to the right and you move into the bigger fleet vehicles, certainly hydrogen has a play there. OEMs are looking at it, we're looking at it, and we understand. From a Toro standpoint, obviously, a lot of that process is, make it agnostic. So we want to make our platforms accept what power solution that you as a customer needs. And so as we move over towards electrification and everything becomes drive-by-wire, whatever, whether it's a battery or a fuel cell or hybrid, that it kind of becomes immaterial, but it's more about kind of where you want to go with your journey based on your needs, your customer needs. But certainly we're monitoring that process, which again lends back to, what does my station look like? Do I need to put a hydrogen station in? Is it coming in bulk? And I would say generally, a lot of that process and that space is still kind of materializing in where it's at, but it's something that we're paying attention to on the outward look. My last slide here is an eye chart, but really I wanted to end here just with maybe a broader view across the Toro company, across our family of brands, and across our different segments we operate in, that we do have electric and hybrid and alternative energy solutions across a lot of these, anywhere from your residential to as you move into professional space with battery, individual battery packs to backpack blowers, into the full construction grade with golf, grounds, and people moving in construction. So we certainly have solutions in all these, and really the Toro position is that we're going to provide the power solution that meets your needs as you look across your product of families. And as we look across and out in our roadmap, certainly we're mapping forward to say that we have solutions across our product portfolio that meets your needs. So I will end it there, and we can pick up any Q&A if there's any questions that came along.
Great, thank you, John. So we do have one question in so far. If anybody watching has any other questions, please type those in and we can go through them. So the first one is to do with charging. And this is something that perhaps Case can touch on as well as they go through. Are the light, medium, and heavy duty equipment manufacturers working to standardize charging equipment, like the J1772 standard for electric vehicles? So they say we have an electric ice resurfacer, but will likely require proprietary chargers for future equipment like tractors, which adds on significant cost. So,
yeah, no, happy to answer that question. I would say generally yes, but it also depends, right? So, again, if you look at the EV journey, Tesla has a unique charging solution. If you look at Europe, they have a standardized to essentially one when it comes to EVs domestically in the US and North America. We're starting to align on towards the one, and you're seeing even Tesla starting to open up their networks to others. So I think a lot of it in the EV car range have kind of gone where they try to provide their own, but I think they're essentially realizing they need to standardize, and the value to the customer to standardize helps them while they can still keep their proprietary solutions. And certainly at the Toro company, we're looking at the same opportunities, right? We want to provide solutions that meet the customer needs, and whether that's, if it's a smaller product that can just plug into 120 or 230 volt, then it doesn't need to be the big J1772 charger. If you get into the bigger equipment, based on, again, that customer need, is it a traditional plug-in with a 230, 120, or is it plugging into the EV? But I think generally you're going to see entrance into the space having that same question, but my general sense, or at least the Toro general sense, is you're going to see a lot, kind of fall, as it becomes standardized, they're going to be following kind of the automotive, because that's what's being put up at charge posts and charge stations, and the infrastructure is being built around more commonized, standardized features. But again, it all comes back, I think, to use case, and certainly whether you're in an urban environment or maybe you're out in a non-urban environment where you don't have access to those, you might be having different solutions based on the OEM. I'd be certainly curious how Case and Zamboni approach that same answer.
Great, thanks. Can you speak a little bit to if a municipality is looking to switch over some of their grounds maintenance equipment, not huge, massive pieces of equipment, is electrical supply at the public workshop, is that typically a problem, or are do these vehicles have small enough battery packs where it's not generally an issue? Yeah,
as you can imagine, it spans the gamut, right? And a lot of it is kind of what's the strategy with the customer and how quickly do they want to convert, right? If they're all ICE engines today and they want to convert to all electric in the next 2 years, then there's a lot to take in there. And again, I think that's where, whether it's John Soda from the Toro Company, otherwise we partner with, if it's a golf course, to say, what is your journey? What's your timeline? And then we have tools we can look at what their power needs are today, what their expected power needs are, and kind of create a vision for them. In some cases, it's pretty simple. It's just add maybe a couple sub panels or otherwise. In some other cases, it's like, no, we want to be all electric by this date. Well, then it is a conversation with their utility provider to say, we need more power brought into on site. So it's a broad range. Generally, I would say that we've yet to encounter one where there's not supply available. There's an infrastructure piece to make it happen from the partner we work with, but it's not like we're talking the product size demand. Even if you took a golf course maintenance shop and everything was electric, including their cars that they pull into the parking lot, I've yet to see it yet where we don't have a supply capability there, but there'll be a lot of those cases where that will be a challenge. But I think that again goes back to, for the partners around the call, where are you at, where you want to be, set your strategy. And sometimes the first thing is just take the first step as you're on that journey. In other cases, they're like, no, we want to get there in 5 years. So it kind of varies on the conversation.
Well, and if I can add to that as well, from the sales side, we're seeing that and we're hearing that from municipalities that have barns, as we call them. They have locations that house their turf equipment that isn't really in a setting that's directly tied to a lot of infrastructure. And so, when they're looking at switching to fully electric vehicles or even maintenance equipment by a certain year, 2025, 2030, whatever the case might be, considering the infrastructure needs is an important piece of that dynamic, and also from a cost standpoint. And I think that that's being overlooked by a lot of people making those decisions. They're looking at the cost difference between the pieces of equipment, but then there's an infrastructure need as well. And so we need to make sure that people are aware of that and considering that component of it. Because frankly, there are people who are having difficulty with getting their barns up and ready for a full electric fleet. And we're seeing that in the West Coast. We're seeing that in Canada. We're seeing it in areas that have this specific requirement, and they're just not ready for it yet. And so they kind of have to scramble and figure it out.
Yeah, John, you have really good comments there, right? I mean, and I think certainly a lot of my journeys and conversations, if it's regulatory or municipal driven, it's, hey, you must do this, but I'm not going to give you many more dollars to do it. So that becomes part of that overall. It's really hard. But in some of those remote cases, if you to that point, if you can't get the power in, then you got to create your power. So do you have solar capabilities? Right. Do you have a battery backup that you can build it into? It's a challenge, and it's certainly, if I'm on a customer side, it's daunting, right? So I think that's where we see a lot of value as we engage our customers and say, how can we help you on the journey? Not only to help you, but it helps us educate ourselves on how do we provide solutions that meet the path and the journey that you're on to get there.
Absolutely.
All right. I've got one other question here. Are manufacturers working with their service centers and technicians to train for future electric equipment and repairs? And specifically on the batteries, will technicians be trained to repair damaged batteries, or will they be replaced or refurbished only?
Yeah, I mean, I guess, general message is yes, we obviously are training our channel partners through dealers, distributors, or whatnot. I mean, they are oftentimes our face and direct interface with our customers, right? They're the ones that kind of boots on the ground. So we need to equip them with the right level of capability to service, repair, maintain. Specific to batteries, I think probably, generally everybody's going to have their own view on it. At least our view right now is that we don't expect our end dealer customers to service the individual batteries, as far as the battery itself. I think it is in a contained enclosure, a lot of requirements around that. So, but we certainly work with them on, whether it's a swap out, if we can, review it, make sure it's okay. There's also right to, kind of the recycling channel part of that. So I think the Toro Company, again, back to kind of our foundation, is we're not going to sell these without having a path to recover the batteries at the end to make sure that they end up in the right spot as they go through a recovery recycle, whether it's recycled back and the lithium is extracted to make the next batteries or otherwise. But we certainly have signed up a lot of partners to ensure that the whole life cycle is covered And we're not, just, shipping batteries in the field that don't have a life cycle on it in terms of, at the end of life.
And again, just to add to it, again, technology is continually changing. So the service folks in the field are having to constantly change and educate themselves, and through training, again, from the Toro company, and I know others on this call are doing the same thing, from training their distributors and dealers, and ultimately the end user service people, mechanics and service technicians, on how to service these types of pieces of equipment. It's not just servicing a combustible engine like they may have grown up with, right? Specifically based on what day and age they grew up with from their training. Training is completely different nowadays. There's a lot more technology that goes into it, especially as we move towards electrification and other technologies. But to answer that question, technology is significantly changing, and therefore the way we're having to train technicians is significantly changing.
Yeah, for sure. Yeah, and even back to kind of component level on that, right? I mean, it's no different if anybody was in the automotive repair space, and 30 years ago you were swapping carbs or doing things like that, and nowadays you're hooking up computer to it, you're checking diagnostics, and you're doing less repair of an actual subsystem and more of a modular replacement. And I think that's, at least on our view, that's what we're going to see a lot with as you move into electrification, whether it be a battery pack or a motor or whatever. It's going to be more self-contained replacing of that. But to John's point, it's a lot of training, understanding kind of what tools they need and how do they diagnose and get the machine back on the road as quickly as possible.
All right. Well, we don't have any other questions, and just being mindful of the time, I think we need to wrap up this part and move on. So thank you very much, John and John. And now we will switch over to Case.
Thank you.
Okay. Can you hear me?
Yep, loud and clear.
And you can also see the screen, right?
Yep.
Okay, great. So I'm George McIntyre. I'm with Case Construction Equipment. Also, we're part of CNH Industrial Company, and I've been with Case for the last 25 years. I'm a product manager and currently work with the backhoe loaders, but I've worked with most of the construction equipment products through the years here. So first, and also with me, I should mention, is Eric Lewis, who's with our government affairs group, and then Bob Newt, who's with our service area out of New England. So a little bit about us as a company, for those of you who don't know. See, these are some of our brands. On the agricultural side, we're known for mainly for North America, Case IH and the New Holland Agriculture. And then for construction, we have Case Construction and New Holland Construction. We're really going to be focusing on what we're doing with the Case brand here. There is work being done on the ag side with the tractors as well, though. We'll be talking a little bit about what our portfolio and plan is, a little bit about charging. We'll be addressing that question that came into Toro regarding the common plugs when we get there. And then Bob Newt's going to cover the dealer and training piece. So if we look at where we're at now, we're certainly not quite as far along as some other industries. Construction equipment is a little bit a different stage, a little bit later for us. I know some of the companies that have smaller types of equipment have moved into electrification quicker. Certainly Zamboni has moved there faster, and then Toro's ahead of us as well. Really, our focus right now is on three product lines, but we're looking at other product lines as well. But these are the first three that we're coming out with that are electrified. First is the mini excavator, which is a great tool. It makes sense to electrify it, especially on the smaller end. We're starting off with the 1.5 ton, which is our smallest model. And then we're bringing up through that line up to the larger models. Also, compact wheel loader is another one we focused on bringing to market as electric version. And then probably the most challenging one right now, and we're going to spend a little bit more time talking about, is the backhoe loader. It is a heavy machine. Backhoes are 15,000 plus pounds. And with that and the requirements for the backhoe to have the front end of the model actually run as well as the back end also leads to some additional challenges. With that, we're going to a high voltage system. So we have low voltage on a mini excavator and compact wheel loader, and then we move to high voltage as we move to the bigger products. So with that, a lot of what we're doing right now is still gathering customer knowledge, customer information from partners like yourselves that are on the call. We'll talk a little bit more about that in a moment, and then we're optimizing our investment in new developments, new features, new models. And then one last thing I want to mention is with all these models, we're making sure that they do have the panel in environmentally friendly oil and grease with that as well. So that this goes into a lot of what we're doing from a sustainability standpoint. Electric is a big part of that. I know John talked about what their focus is for Toro. It's very similar for Case, is that sustainability. So if we look a little bit closer at mini excavators, this is the first one we've launched that's fully electric, with the CX15 EV coming first. We have information, if you go to kce.com, about this model. It is being sold through our dealer networks. And then next in the lineup will be the CX25 EV model, which will be released a little bit later this year. If we look at electric, and I'm going to use the backhoe as an example again, because this one is probably the one that's taking a little bit more work because of the customer requirements as far as the applications and the performance of the machines. We're really using this, and this could be used for other product lines as well, as kind of the high level umbrella would be the electrification. And with that comes a lot of pieces to it, which is electro-hydraulic controls for both the backhoe and the front loader. And then we drive that down into the electric powered products. Obviously, that's what we're mainly discussed today, but there are advantages to the diesel powered as well. As we develop this technology, we're able to move that technology downward to the diesel powered models. And then longer term, we do expect that the diesel powered models kind of start to go away. So by 2030, 2035, we'll see a huge reduction in the number of diesel powered units as we move to electric powered. And then even longer term than that would be going to fully electric using electric actuators. So right now, our backhoe version is basically, and I just move to the next slide here. We have actually two split powertrains. So we're still using the hydraulic flow. We have one motor assigned to that and another motor assigned to the powertrain. When you look at construction products, one of the challenges that you have is the front attachments. A lot of what's been developed so far is for hydraulic driven attachments. So going to full electric attachments is going to take more time. So the intermediate step that we have here is going to an electric powertrain and then still having hydraulics until we move to the next step, which will be going to electric actuators, for example. So some of the advantages to electric, obviously, I think a lot of you would know this, would be the instantaneous torque that you get, low noise for job sites. So think about somebody's operating a piece of construction equipment near a residential area. They a lot of times would have parameters we're not able to operate during certain times of the day. If you're able to do this, it pretty much eliminates the noise to just hydraulic fluid noise and what you'd hear with the bucket and other like movement of the machine. Really, it removes all engine noise completely, of course. Zero energy waste, and then it's easily tunable is another advantage for going that way. So regarding the number of hours of work time, we get this question probably the most often of any question. Really, our target is 8 hours, but we do say, and what we have right now is 5 to 8 hours, and it really depends on what type of operation you're doing. And I'll talk a little bit more about that as we get into one of the later slides. Air quality. Air quality is very important. staff, for people that are around the machines that are unrelated to the work that's being done. Just the overall environment is improved with it. And then the savings, which was mentioned by John as well. So some of the things we see is no fuel required. So diesel fuel is quite expensive. Some of our machines could be a couple gallons of diesel burned per hour. It adds up quickly. So you're removing that part of the investment, and then you don't have the engine oil and then DEF fluid, which is required for most of our medium to heavy equipment, and then zero engine maintenance that goes along with that. So if we look at the profiles for our types of equipment, really 3 stand out. There's some other secondary ones we didn't include in the slide here. But number 1 would be utility segments. We have had 2 different utilities approach us a few years ago. Avangrid and National Grid are both global companies in the utility segment. In this case, we were working with their headquarters out of New York State, and they approached us and said, we have R&D budget. We would like Case to work with us on electric backhoe. They are also involved with electrical or electricity generation as well. So it really makes sense for them to want to have all their fleet, trucks, construction equipment, everything electrified. So we have been working with those 2 partners over the last few years, and I'll talk a little bit more about that as we get to the next slide. And then another area of focus and really a lot of interest has been cities and municipalities. Particularly if you look at the 2 coasts, the West Coast and East Coast. And in Canada, there's been interest out of Vancouver, for example. We've had interest from pretty much every major city you can think of, even in Texas, which you're thinking it's oil country there. The city of Houston's kind of approached us about getting some machines as well. So there's a lot of interest from a lot of different customers that are out there, especially when it gets to city and municipalities, working in that urban environment where charging infrastructure is a little bit closer than if you look into the more rural areas. And then last one I want to touch on is the general market. If you look at that, really what we're looking at again here is urban environments in particular, and then you have local regulations that are driving a lot of that too. So if we look at a little bit about the concepts testing that we've done so far, we introduced or showed the first concept machine at ConExpo in Las Vegas, which is a big construction equipment and aggregate show that happens every 3 years. We showed it first in 2020. There was a huge amount of interest in it. During the show, to gauge customer interest in it, we did go ahead and survey quite a few of customers there to get their feedback. We did have the partnership with these 2 utility customers in New York State, which we built 2 machines, placed them with these customers, and then we've been getting feedback from their crews that have been out operating electric backhoe and using that information as we design the more industrialized version that we're coming out with in the next 2 to 3 years. And then we've done a lot of other things as well with regional product management. We've had weekly design reviews, a lot of 3D mock-ups, physical mock-ups, and so on. And then we've also working on early builds that we're going to be placing with customers as well. And one of the other items that's been valuable for us is reviewing telematics data that we have been getting or gathering for our diesel powered units as well to help make decisions regarding things like idle time versus operational time, for example. So if we look a little bit more at the user segments that we're looking at, again, with the backhoe being an example here, we're doing this for all of our electric product lines as well. So if you start looking at the different activities and what it means for the electrification, so when you look at a backhoe, 60 to 70% of the use of a backhoe is generally on the back end of it where you're digging a trench. And really, when you look at electrification, it really is geared well towards that particular type of an operation. What's not geared quite as well is when you're roading up hills, for example. It's going to be a bigger battery drain, roading from site to site and so on, and loading type of operations have an actual more of a draw on that battery than what you see for trenching. So when we said 5 to 8 hours, the 8 hours would be more if you're trenching for a good portion of the day, and if there's a lot of idle time is, for example, if you're doing a street repair, a backhoe will go out to do the repair, whether it's on a trailer or roaded to the site. At that time, it'll break up the concrete or asphalt with a hydraulic hammer, and then they'll go in and say it's a water main break. They'll go in and fix the water main break, and then the backhoe will help fill that hole at the end of the job. So there's a lot of idle time, and when a backhoe is idling, basically there's no power consumption when you have an electric version of it. So that's the great use case for a backhoe, great for doing repairs and that type of work. So I mentioned ConExpo. We did show additional machines just recently, earlier this month in March, was ConExpo 2023 in Vegas. We showed several products there, or several models, I should say, including the backhoe, the mini excavator. We had a little bit of a demo there. You see the guarding around that area as we did demos. And with that, I would say, of all the different areas and machines that we had there, we had over 60 different pieces of product there. The most interest that we were hearing back from those visiting the site or our booth was regarding electrification. So there's a huge amount of interest in it. We know there's some governmental regulations that are really telling us that whether the brands that are out there want to or not, we're going to have to get into electrification, and we're doing it because we want to, and there's a lot of reasons strategically to do it, but there's also regulations that are coming down the road which will require more and more electrification of products. All right, so with that, talking about charging, so there's some questions that came in to Toro earlier. We'll address it as regards to how CASE is handling it. So the question was about the J1772 automotive standard. Yes, we are trying to, or we want to go to that standard, and that is really what our focus has been on, having that charge port protocol be what we are kind of going towards. So with that said, as far as the electric charging goes and what the requirements are, it really does vary by which product line it is, going from a low voltage system to a high voltage system, for example. For the backhoe loader, for example, we are suggesting a 240 volt, three-phase system for that, but you can charge on 120 volt as well. It just will take a much longer period of time. Talking about the charging offering, these are being rolled out this year as these are the first electric products that we are actually bringing to market. So you can see there's a lot of variation on the charging solutions that we have available. It can be anywhere from 10 hours to 2.8 hours, as shown on the slide, depending on which systems adopted. And then later on, we are looking at a premium fast DC charger as well. So with that, I'm going to turn it over to Bob Newt, and he's going to talk a little bit about the training piece of this and the support.
Yeah, good afternoon, everyone. Thanks, George. And thanks, John and John. You guys really laid a great foundation for the rest of this conversation, because we are on parallel paths. There is no doubt. I want to stop before I start the training portion of this and just talk a little bit about the battery question that came up, the end of life strategy. That's one of the things that was most important to us as we started in with the loader backhoe and developing an end of life strategy, so that we know that we're making sure that what happens to the batteries at the end of their life is good for the environment and maintaining that sustainability thought process. we had to do that in order to make sure that we were first in line for that very important piece of this. And then again, we've worked with diesel for 130 years. We've worked with gas a lot longer. And now we are throwing something completely new and different to municipalities, to golf courses, to agriculture, and to our dealers as well. And we have to be prepared to help them navigate that pathway. And it is one of safety first. And from a municipal training perspective, that safety is of utmost importance. When we have low voltage, it's still an electric voltage that will, if not treated properly, will hurt you. So we've created 2 fundamental courses, a safety course and an introductory class. Those are the first trainings for our technicians at our local case dealers. And then we will have a secondary high voltage class, which will take into consideration more of the in-depth process. Another question came up about the repair of battery packs. We don't expect that that's going to take place for a longer period of time. Obviously, with the warranties, it's going to be a replace component, and it will not be a diving into the battery packs because we're not ready for that yet. You're not ready for that yet. That will take some time and some intense training. But we will provide all this, and we're ensuring that our dealers all have the necessary safety equipment that they need to work with both on the road and in their shops. And their technicians will also be responsible for having high voltage training as next steps. So yes, George talked about the 1772. It is high on our list to make sure that we get that 1772 process into the majority of our products. The mini excavator, the 1.5, that can be charged on 110, which makes it simple, but it's a 10-hour charge. And again, that charging strategy that all of us are working so hard to find the right one. For the Toro guys, they go back to the barn at night. For the construction guys, we stay on the job site, so it becomes a bit more of a challenge for that. And we are actively looking at some different charge strategies, which include solar, hydrogen, etc. So all of those things taken into consideration make this a very interesting journey for all of us to be on, for sure. Next slide, George. Some of the tools that the dealers are going to need and municipalities will need to, just for de-energizing or taking the battery out of play, your class 0 gloves, boots, some arc flash coveralls, a shepherd hook to, because you're going to use a 2-man safety protocol when you de-energize, a shepherd hook is necessary in the event that someone needs to be pulled off a live line. A perimeter kit, our shops are going to be segregated to have special electrification areas for that electrification work to take place. So all of those machines, lockout, tagout kits, and the hard hat. And some of the typical tools that you already have, your AC equipment, and then obviously, as John and John both alluded to, your charging infrastructure. And our dealers are looking at the same thing and understanding just exactly what they have, what their capabilities are today, and what they're going to need tomorrow. Critical pieces of that infrastructure conversation that we're having with them right now to try to prepare them as these machines come out. George indicated that the 1.5 is out now and available, but the 2.5 will be coming out later. And as we move forward into the commercialization of the 580 loader backhoe, that is going to require another level of charging infrastructure. Next slide, George. So at this point, if there's any questions, go ahead and feel free to type them in. I know that we all, as I said, are traveling this pathway, and the questions become more and more as we consider or as we make those considerations for the journey to electrification.
All right, thank you, George and Bob. Got a couple of questions that have come in already. First one is about batteries. Can you speak to how long the batteries will last for a typical mini excavator or backhoe? How often do they need to be charged, and what effect does heavy excavation have on their operating time?
Well, I'll go to the last one first. Obviously, heavy excavation or heavy work with the machine is going to draw your battery down, but just like we did with diesel, we learned how to operate them, and we're going to have to learn how to operate the electrics as well. Again, something completely new and different. Our charge time expected right now on the mini excavator is 6 to 8 hours. And when you think about it, you don't necessarily use that machine every minute of every hour. And when you're not on a control or commanding an operation, it is not expending any battery. So we're saving there. But again, it's part of that learning process that this is all so new for all of us. And what was the third part of that question?
How long the batteries will last, and how often do they need to be charged?
So charging, it all depends on how much battery you use. So if you're comfortable depleting 50% and you know that you're not going to do anything for the next day, you don't necessarily have to charge it that day, but plugging it in overnight would be the best solution so that you have a full 100%, especially on the mini excavators. On the loader backhoes, that is going to be driven by what capabilities or electrical capabilities you have on site.
All right, and how long do the batteries typically last? Just the overall longevity of them?
The overall life with the mini excavators, we're expecting an 8,000 hour charge cycle. So approximately 10 years.
All right. So the next question is about the backhoe. How much is it, and what's the waiting time from order to delivery in British Columbia?
We have not
Okay.
established any pricing yet, but George, I'll let you take that.
Yeah, we are still looking at the pricing. As a rule of thumb, if you look at the construction equipment segment, you can say it's about 2.5 times the price of a diesel powered equivalent model. So that can kind of give you kind of an idea of what the pricing would be, but we really haven't even decided on the exact price yet. And then as far as delivery goes, everything we've talked about today would be within the next couple of years. We are not going to give an exact timing on the backhoe because we want to make sure the timing we give is correct. And we're not going to launch this product until we make sure the quality and everything else that our customers expect is ready.
The other piece of that cost conversation, though, is thinking about the overall cost. There are state, federal, and local incentives that are available for purposes of electrification for both municipalities and for general contractors. So something to keep in the back of everyone's mind is looking at those incentives that do become available.
Yep.
All
Very
right.
good point.
So one more question about the backhoe. What is the road speed for it?
So road speed is equivalent to what we'd see on the diesel powered version, which would be about 25 miles per hour.
All right.
And Tanner, if I can add something just to the pricing conversation for batteries, is right sizing the equipment that John was talking about earlier as well. And I know George and team Bob have talked about this as well. Is Bob just mentioned equipment lasting, 5 hours or so. And you get operators who think, well, I need this for 8 hours a day because it's an 8-hour shift. And so there's a education piece here that people need to really understand how much they're using the equipment. And a great example of this is a research study that we did on our utility vehicles, where we get people asking, we need our batteries to last us 8 hours a day. We're operating at 8 hours a day, but a utility vehicle is used to get to a job site and then it sits. And so the study that we ran is they're really only operating it around 2 hours a day. And that really floored a lot of people. So the key is the batteries are expensive. So we need to right size the equipment to make sure that they're not overbuying. So we could build backhoes, we could build utility vehicles, tractors, mowers, whatever, to get to people's expectations so that we can say that they last a certain amount of time, 8 hours a day, but in reality, they're not going to use it that amount of time. And so there's a bit of a perception here that people need to understand that, again, we don't want to overcharge or build the price to a certain amount. We need to build the right size battery and equipment to meet the job needs. And people need to understand that how they're using that equipment. And there's a big component to that associated with the price.
Great points, John. Great points.
Yep,
It's
absolutely.
so true.
Great, thanks, John. All right, one more quick question, and then we'll move on to Zamboni. So when will the SL22 EV be available?
George?
Well, that the SL22 EV was something we did show at ConExpo. Timing for that is similar to what I had said before with the backhoe loader. We're evaluating timing on that, and it's going to be within the next couple of years. Though everything that we showed at ConExpo, including that particular model, is within the next 2 years.
Great, thank you very much. All right, so thanks to the case team, and from here we're gonna hand it off to Greg at Zamboni.
Tanner, I can't start my video. I think you have to start it.
We should be able to.
Oh, okay,
There we go.
fine. There we go. Good afternoon, everybody. I'm just gonna get my screen share going here. I'm a little bit of a newbie with this. Sorry, my computer's not cooperating. Just bear with me. Okay. Tanner, can you see my screen now? Sorry, I'm just having some technical difficulties here.
Yep, everything looks good.
Okay, great. Thank you, Tanner, for inviting me to participate in this webinar. This is one of several that we've done with the Canoe procurement group in LAS. And I know that several people who are here have probably attended this in the past. So I'm going to try and keep it the commercial down and keep it to some of the more general issues and topics related to electric ice resurfacers. Today, I'm going to be talking a little bit about the products. We try and keep it generic, but my brand team really likes to show Zamboni pictures, and I do get paid to do that. So I'm going to talk a little bit about the battery options that are available. Also about charging infrastructure and requirements and how an electrical ice resurfacer can be applicable to your arena facilities. So while everybody is talking about sustainability, carbon reduction, the environment as it's a new thing, one of the things I just like to point out to people is that for a Zamboni machine or an ice resurfacer in general, electrification has been around for quite some time. Zamboni company started in the 60s with our first electric machine. It was not a commercially produced machine, but in 1978, we started producing electrically powered machines and really ramped up in 1990s with the Model 552. So over the years, we have continued to develop and add models to our product lineup and our electrical lineup. Europe has been a big generator of electrical machines for many years, or customer. Quebec has been a very big consumer of electric machines for quite a few years. Ontario is really just starting to turn the switch. British Columbia and Alberta are also becoming very reliant on electrical machines. So this just gives you a quick overview of the models that we have. Currently, we have 3 electric models with various battery configurations. So in the past, we've always powered our machines using lead acid. One of the main reasons is that it's very common with industries such as forklift, 80-volt power, readily available. It's just been the technology that we've had. There are some advantages with lead acid. More recently, 2018, we introduced lithium-ion batteries to our product lineup. What we are finding now is that while lead acid are still a fairly significant portion of sales, lithium-ion is quickly catching up and surpassing the lead acid. There are pros and cons for each type of battery. Lead acid has a lower capital cost and longer run times on a charge, but you require ongoing maintenance, watering, equalized chargings. There's some off-gassing, and there's some other handling issues that come with lead acid, but it's been a workhorse for many years and certainly can work in an arena environment. With the LI, there is a higher capital cost initially, and there is a shorter run time between charges. I think George or one of the other gentlemen from Case were talking about right sizing the battery. I'll talk a little bit about the lithium ion and right sizing it for our application. But the lithium ion batteries are maintenance free, no emissions, and generally have a longer lifespan than lead acid batteries. The LI requires multiple plugging in during the course of the resurfacing day. So that's something where education and usage is important for the operators. So I'm going to focus a little bit more on the lithium ion side because that has been the bulk of the requests that we've been getting related to battery machines, electric machines. So our philosophy with the lithium ion has been resurface, recharge, and repeat. Because of the cost of the batteries, we've tried to right size the batteries for the application. So based on that, the machine is, we go out and resurface, we recharge it, and then we go out and resurface again. So we tend to try and keep the battery in the 40 to 80% range through the course of the day. And by doing that, you pretty much have unlimited power within most facilities. Why is lithium ion or electric suited for the ice rink market? With the lithium ion, it affords operators a fast return to the ice with a maximum capacity and can support a busy arena schedule. Lack of zero battery maintenance. I don't know how many of you deal with ice rink operators, but if you can't get them to grease a conditioner, it's a challenge to get them to maintain and water a battery. So with the lithium ion, they don't really have much they need to do. The lithium ions are controlled by a BMS, battery management system, for smart charging, so it helps to maintain the battery levels and life. We have extended battery life over the lead acid. There is a reduced cost of ownership with electrical in general and with lithium ion. Electric, it is a green choice. Lithium ion batteries provide net zero alternative, creating a safe and healthy environment. Lead acid batteries are pretty much, I think, run about 95 to 98% recyclable. So from that standpoint, they are a very good green choice. With lithium ion, there is still some challenges related to recycling. We are working with several companies about end of life of the batteries, and we expect that the future state to be that there will be a much higher percentage of recycling of the battery components. Right now, I believe we're about 50%. Battery and electric machines, there's definitely a fuel savings over fossil fuels. And then the zero emission aspect of electric machines, which helps with the environmental aspects of your building. It's ideally suited for an indoor building where you have public and people in the building on a regular basis. Just to talk a little bit about lithium ion versus lead acid. Lithium ion we feel is suited for the ice rink industry because you discharge, recharge, discharge, recharge, discharge, recharge as needed with unlimited power. And you have a continual constant power supply. With lead acid, you tend to have, you charge it overnight. In the morning, you have your 100%. And then during the course of the day, your power is declining until you get down to your end of day. And then you are recharging between 5 and 10 hours overnight to get back up to your 100%. So there are some considerations to be taken when deciding between lead acid and lithium ion, and things like equalization charge. Once every 2 weeks, you may need to do a 12-hour equalization charge on your battery. So we feel the lithium ion is a better choice currently. Again, I think I've covered this. Zero emissions with electrical, no fuel consumption, no off-gassing, zero emissions. Some of these are the key points that have been discussed with municipalities in the press. And certainly every time there is an event related to air quality within an ice rink, there is more and more requests and discussion about electric machines in ice rinks. Essentially, the lithium ion battery pack that we have is controlled by a battery management system. So we call the BMS the brains, and the lithium ion battery is just the storage for our electricity. What does the BMS do? Within the battery pack itself, we have multiple modules. It could be 4, it could be 6, it could be 8, depending on the battery size. The BMS is the smart part of the system that as the batteries discharge, they may become unbalanced. One may discharge more than the other. The BMS itself ensures that the batteries maintain balance and maintain equal charge. This helps with maintaining a longer life and ensuring that the batteries are there when you need them. The parts of the battery for the lithium ion within the battery pack, we have the individual modules or cells that make up the battery pack. We have the BMS, which is the brains. And then what we have is the BMS controlling the active balancing of the cells to ensure that they are all up to the same voltage at any given time period. One of the things that people ask us about is lithium ion safe? Yes, lithium ion is safe. And what we did is we went through the various chemistries that are available for lithium ion batteries, and we determined that lithium iron phosphate batteries are the best, were the best choice for our use. Being in an indoor arena, safety was paramount and one of our primary concerns. So if you take a look at this graphic, you'll see that the different applications, cell phones, electric vehicles, smaller electrical devices, they all have different types of battery chemistry. The lithium iron phosphate that we chose is high on the safety side, which is important, long on the lifespan, which we feel is important, has good specific power for what we need, and a lower cost. So it really seems to suit our environment. LFP has a lower energy density than other chemistry, but that works well in an arena environment where the machine stays in the building. Out of every given hour, it could have an hour, 40 to 50 minutes of downtime where you can plug it in and recharge. So the LFP was our choice for those reasons. Just as a general cost of ownership, we typically find that over the 10-year lifespan of a machine, there is an operational savings to running the electrical machines. There is a maintenance savings where you don't have oil changes, you don't have some of the wear and tear parts that you have on fuel powered machines, and you certainly don't have the cost of fuel. Typically, you'd see, depending on the length of operation of the ice season, you're probably looking at somewhere around a $3,000 to $7,000 a year savings. It's fairly simple to look at your propane or natural gas consumption, determine what you're spending on that, and you're going to save a significant chunk of fuel costs. So in terms of within your building, one of the questions that or points that Tanner wanted me to discuss was the charging infrastructure. So we get a lot of questions for that. Currently, we do not use an onboard charger or have the ability to use an EV charger, the small charging ports that you see in buildings. That is coming. We do use a significant charger. Typically, we're running on 600 volt in Canada, in Ontario specifically. We do have options for 208, 240, 480, 600 volt. We require 3-phase power. We require a battery disconnect, and typically we need to have space that is within the ice resurfacing room, within 20 to 25 feet of the machine, and it needs to be a relatively dry environment. We typically, well, with this particular model, you'll see that we have a charging stand. We provide that as part of the charging package to keep the charger up and out of the way of the water, and does not require a housekeeping pad. Some of our other models, 650 and 552 AC, utilize a smaller charger. This is a high frequency charger, and in particular, this model can be wall mounted or bench mounted. And again, 600 volt, 480, 600 to 208, 240. We have all the varying voltages. So one of the things you have to look within your facility is what power do you have? It will be 3-phase required, and where am I going to locate this charger? We don't really have the same issues that Case and Toro would have with remote charging stations, or having the machines out in the field. We typically are in an environment where the charger is located fairly close to the machine. And that's about it. I'd like to thank LAS and Tanner for the invitation, and see if you have any questions.
All right, thanks, Greg. So we'll give a few minutes for people to type in questions if they like. But I think Zamboni probably has a unique situation where you've been producing electric models of your equipment for quite a while compared to other manufacturers that are just looking to join in now. So are there any lessons learned from switching between fossil fuel and electric over the course of several decades that may be useful to municipalities looking to make the switch with other equipment?
Yeah, definitely there is a learning curve for operators, because they need to get it in their mind that with fuel powered machines, you essentially can continue to go by changing tanks if they're propane, filling the gas tank if it's gasoline. Natural gas tends to be a little more along the lines of electric, as you have a slow fill station, so you need to be aware of the fuel levels. But with electric machines, at some point, that machine is going to need to see the charger to get refueled so that you can go out and continue to resurface. So it's a little bit of a mindset with the operators, particularly with the lithium ion machines, where we have somewhere between 6 and 9 resurfacings in the bank, and we need to go back and plug in if we've got a heavy flood schedule. But as long as they recognize that the machines need to be plugged in when you start getting below 80%, then we usually don't have an issue with the operators. As far as power capability of the machines, we have not really had any issues with people saying lack of power, or the electric machines are not as strong as fuel powered machines.
Great. Okay. We've had quite a few questions come in, so we'll try
Oh, all
I
right.
do this lightning style. So we had a few questions on the 552.
Yes.
So is it still made in California?
Yes, the 552 AC lithium ion and lead acid are still made in our factory in California.
Okay. What's the current lead time on that model?
18 months.
All right. And how much time does it take to charge?
Typically our charging scenario is for about 10 minutes of usage, which is about the average resurfacing. You're looking at about a 15-minute charge time. So if you were going down to about 20%, you're probably recharging to 100% within an hour and a half. So it's fairly quick charge. Our strategy is to make sure that we don't charge the batteries too fast, generate heat, and shorten their life. So our charging plan is essentially to maximize the lifespan of the batteries, but still make it usable for the ice rink environment.
Okay. Well, tied on to that, what is the lifespan and replacement cost for the lithium ion batteries?
Okay. Well, we've been doing these since 2018. We still have the majority of the batteries in place. There has been a few glitches and battery replacements that have been covered under warranty, but under our charging scenario and charging strategy, we're expecting an 8 to 10 year lifespan on the battery at the lithium ion batteries, as compared to 4 to 6 years on a lead acid. Replacement cost on a lead acid system is running about $15,000. On a lithium ion system, you're looking at about $25,000.
All right. A few more cost questions. We've got 2 here. So what is the price difference between ice and electric? And then kind of, I guess, a sub question there is, what's the cost difference between lead acid and lithium ion?
Okay, fair enough. So between fuel and lithium ion, you're probably looking at about a $40,000 to $50,000 upcharge, depending on the model, depending on the features on the machine. Between lead acid and lithium ion, you're looking perhaps about $20,000 difference in price. With all the inflation that's been going on, certainly everything's been going up in price. Lead acid batteries are no exception. They have increased significantly, and lithium ion are also increasing, but not as quickly.
Okay. I've got a couple of questions here that I think I'll tie together.
Okay.
So how, in terms of sales comparison, the ratio between electric to fossil fuel, where is that at? What is the trend showing, and how soon do you see a point where there are no longer any fossil fuel units being produced?
To answer the last question first, I don't see a point where we will completely eliminate fossil fuels. There are applications that are designs that are ideal for fossil fuels: outdoor ice rinks, larger ice surfaces, we build gasoline, natural gas, and propane machines here in Brantford, electric and fuel powered in Paramount, and in Sweden we build primarily electric, but we also have a Euro 6 diesel and diesel versions over there, which are for the larger outdoor ice rinks. So for Zamboni, I don't see there will be a point where we completely eliminate fuel, particularly with outdoor applications. But I do believe that the time is coming where you will start to see fuel powered machines mandated out of ice rinks. And sorry, what was the first part of the question?
The ratio of electric to fossil fuel.
Okay. That's a regional question. We have over 200 electric Zambonis alone running in the province of Quebec. In Ontario, we're getting better, but we're still in the 50 to 60 range. So we've got a ways to go. Our production facilities in Paramount, California, we're running about 60% electric to fuel. In Brantford, we're running about 40% electric, 60% fuel. And in Europe, it's about 90% electric with 10% being fuel.
All right.
And and the trend is definitely towards electric. Every bid that we see out from municipalities these days, if they're asking for a fuel machine, they're also asking for an electric option.
Okay. What are the estimated number of floods per charge for the different models? And is that an NHL size rink or Olympic?
Typically, we're going to base it on an NHL size rink. Olympic ice surfaces are about 15% larger. So depending on, we also have a lot of community rinks that are 80 by 180 and smaller. So we typically base it on the 85 by 200 foot NHL size. For the Model 450, it has a 215 amp hour battery. Depending on how hard you cut and how fast you drive, we have about 6 resurfacings on a single charge. So again, the idea is to go back and, when you get down to 50%, start plugging it in between resurfacings. It should get topped back up. With the 552 Li and 650 Li, typically you've got about 9 resurfacings in storage. And again, that's going to vary depending on how deep you cut and the operation of it. Again, the whole idea with the lithium ion is to keep plugging it back in. With lead acid batteries, depending on the battery pack size that you put in, you should see in the neighborhood of about 18 to 20 resurfacings for the course of the day. With the charging that we're using, there is also the ability to opportunity charge lead acid batteries, which is once they're below 80%, you can plug them in and top them up.
Okay. Is there an extended warranty option on the batteries available for purchase?
The batteries come with a 5-year prorated warranty. We don't have an extended warranty program on the batteries themselves, but it's something I can certainly work with our suppliers on to find out if that is available.
Okay. And do you know of any government programs available in Canada to assist with purchasing electric ice resurfacers?
Federally, there is a Federation of Municipalities of Ontario funding that is available for complete elimination, or not complete, for reduction of greenhouse gases within a facility. Now that funding is predicated on the whole building reducing greenhouse gases by a certain percentage. An electric ice resurfacer can be one component of receiving funding from that grant. Depending on the operation and usage of the machine, an electric ice resurfacer can contribute between 16 or reduce the greenhouse gases by between 6 and 19 tons of carbon emissions. So you could look at that as one component of your overall plan of reducing emissions within the building. Certain provinces have prescriptive measures related to funding of electric machines. The best one that I've seen is Alberta with the MCACC, Municipal Climate Change Incentive. They're offering up to $50,000 prescriptive for switching from a fuel-powered ice resurfacer to an electric ice resurfacer. In British Columbia, there is a up to $5,000 incentive for the charger purchase. Ontario, I'm not aware of anything currently that is available provincially, and the same for the East Coast. I'm not aware of anything provincially right now.
All right, well, we've run out of questions and we've run out of time as well.
Right.
So thanks to everybody who joined us today. Thanks to all of our presenters. We'll be sending out, as I said, a follow-up email either this afternoon or tomorrow with contact information for all of our presenters, a link to the video, and potentially some other information. So thank you, everybody. Have a great rest of your week.
Thank you, Tanner.
Thank you, Tanner.
Thank you, Dan. Thanks, everyone.
Thank you.